It's a pleasure to have you join me on this virtual journey. Welcome. Welcome, welcome, welcome. We're thrilled to have you here as we tackle Clone Java method. Clone is a method in the Java programming language for object duplication. In Java, objects are manipulated through reference variables, and there is no operator for copying an object. The assignment operator duplicates the reference, not the object. The clone method provides this missing functionality. As we transition, let's shed light on overview and its relevance to our ongoing exploration. Classes that want copying functionality must implement some method to do so. To a certain extent, that function is provided by object-to-clone. Clone acts like a copy constructor. Typically, it calls the clone method of its superclass to obtain the copy, and so on until it eventually reaches object's clone method. The special clone method in the base class object provides a standard mechanism for duplicating objects. The class object's clone method creates and returns a copy of the object with the same class and with all the fields having the same values. However, object-to-clone throws a clone in its operated exception unless the object is an instance of a class that implements the marker interface clonable. The default implementation of object-to-clone performs a shallow copy. When a class desires a deep copy or some other custom behavior, they must implement that in their own clone method after they obtain the copy from the superclass. The syntax for calling clone in Java is assuming ob is a variable of a class type that has a public clone method. Object copy equal obj clone, or commonly, Miklas copy equal Miklas obj clone, which provides the typecasting needed to assign the general object reference returned from clone to a reference to a Miklas object. One disadvantage with the design of the clone method is that the return type of clone is object and needs to be explicitly cast back into the appropriate type. However, overriding clone to return the appropriate type is preferable and eliminates the need for casting in the client using covariant return types, since 5. Another disadvantage is that one often cannot access the clone method on an abstract type. Most interfaces and abstract classes in Java do not specify a public clone method. As a result, often the clone method can only be used if the actual class of an object is known, which is contrary to the abstraction principle of using the most generic type possible. For example, if one has a list reference in Java, one cannot invoke clone on that reference because list specifies no public clone method. Actual implementations of lists like ArrayList and LinkedList all generally have clone methods themselves, but it is inconvenient and bad abstraction to carry around the actual class type of an object. Now, let's shift our perspective and explore alternatives through a fresh lens, unlocking new perspectives. There are alternatives to clone, notably the use of a copy constructor, a constructor that accepts as a parameter another instance of the same class, or a factory method. These methods are not always adequate when the concrete type of the clone object is not known in advance. However, clone is often not adequate either for the same reason, as most abstract classes do not implement a public clone method. Also, the use of serialization and deserialization is an alternative to using clone. Prepare yourself for an eye-opening discussion on singleton pattern in the upcoming portion of this video. When writing a class using the singleton pattern, only one instance of that class can exist at a time. As a result, the class must not be allowed to make a clone. To prevent this, one can override the clone method using the following code. Public object clone throws clone in its operated exception, throw new clone in its operated exception. This is only necessary if a superclass implements a public clone method, or to prevent a subclass from using this class's clone method to obtain a copy. Classes don't usually inherit a public clone method because objects doesn't have a public clone method, so it is usually unnecessary to explicitly implement a non-functional clone method. Now, let's delve into the intricacies of class hierarchy and explore its various aspects. To provide a properly clonable object of any type, the clone method must be both declared correctly and implemented correctly according to the convention described in object-to-clone. Every type that needs to be cloned must have a public clone method in its own class or a publicly accessible clone method in one of its parent classes. Example: to invoke clone on Vary, which is of type Y, then Y or a parent of Y must declare a publicly accessible clone method. Here, it is the parent class X that provides the public clone method. Public class X implements clonable public X clone throws clone in its appended exception return X superclone. Public class Y extends X. Public class Z extends Y. Public class test public void function throws clone in its appended exception Y vary equal new Z, Y vary equal Y var clone. To every class that implements clone should call superclone to obtain the clone object reference. If the class has any object references that must be cloned as well when deep copying, for example, then the clone method should perform any required modifications on the object before returning it. Since object clone returns an exact copy of the original object, any mutable fields such as collections and arrays would be shared between the original and the copy, which in most cases would neither be expected nor desired. Example: since class Z contains an object reference, its clone method also clones that object reference in order to return a deep copy of the original. Public class X implements clonable public X clone throws clone in its appended exception return X superclone. Public class Y extends X. Public class object implements clonable public object clone throws clone in its appended exception return object superclone. Public class Z extends Y private object SOMAC. Public Z clone throws clone in its appended exception Z news equals Z superclone, new SOMAC equals SOMAC clone. Return news. Public class test public void function throws clone in its appended exception Y vary equal new Z, Y vary equal Y var clone. Without further ado, let's move on to the topic of pitfalls. If every class in a hierarchy implements a clone method, all of these functions will be called upon cloning, adding some overhead. Over many iterations, this overhead could become significant. With complex object graphs, deep copying can also become problematic when recursive references exist. It is not always appropriate to have multiple copies of the same object floating around. If the purpose of a specific clone implementation is not fully understood by consumers, it may unintentionally break the single object, multiple references paradigm. Brace yourselves for the next chapter, where we'll be dissecting final fields. Generally, clone is incompatible with final fields. Because clone is essentially a default constructor, one that has no arguments, it is impossible to assign a final field within a clone method. A compiler error is the result. Where the value of the field is an immutable object, this is okay, just let the constructor copy the reference and both the original and its clone will share the same object. But where the value is a mutable object, it must be deep copied. One solution is to remove the final modifier from the field, giving up the benefits the modifier conferred. For this reason, some programmers suggest to make the objects in the hierarchy serializable, and create copies by serializing the old object and then creating a new object from the resulting bit stream, which handles final data members correctly, but is significantly slower. Alternatively, one can return a completely new object from the current object's fields, which can be done first calling the constructor, and later assigning non-final fields. Another alternative method is actually making the idea formal, creating a copy constructor that takes an instance. In fact, that is what is recommended over clone by some people. I hope you learned something new today. Let me know what you found most interesting in the comments below.